it can, because in the past, if people want to collaborate, there's all kinds of trust issues, So, so if you say Uber here building the biggest network, and I'm the number two taxi provider, and you guys are the other taxi providers in the city. Can we collaborate together to compete against Uber? Probably not, because there's all kinds of trust issues. You won't trust me, and I wouldn't trust you. And when we make money, there's endless calls. There's a sea of legal work that's gonna drown all of us. So that has never been possible before, right? But with blockchain, there's this idea of smart contract or code is law, is to write everything into code, write everything into something called smart contract, write everything into the network protocol, so that when we execute those protocols, everybody knows who's getting what. It becomes really transparent, it's much more stable and much more enforceable on the network level than a legal contract. So that's, you can say this is a pipe dream. This will never happen. I'm only saying this because I don't understand human nature. I don't understand the legal system. It's maybe true, but as all innovations, even if there's a chance for this to happen, this is something huge. Because this is fundamentally change how the human society is being organized, right? So this is I think it's placeholder VC. It's the guy who used to work at Unix Research. And so he came up with this idea to say, for the internet age, the protocol has very little value. You have HTTP, you have SSL. We all seen, I think last year or maybe the year before, SSL has a bug, and then we all realized there was just one developer working on it, right? Hired by Google. That's so critical piece of software on the internet that just one person tells you the kind of value it captures is very little. And but application captures all the value because because application can be built by a single company. Facebook captures all the value. And the crypto tokens, however, have a different value stackups. So you see the protocol there has much more value because it's run as a non-profit. It's run as a network, as a native network, not a corporation-run network, but a native network. So how the network's self-governing rules and the code that governs the act and the conduct of the network is much more valuable now. So that's the notion that the protocol level is very high, and it has high value, and the application level has very little value. So that explains the phenomenon where the coins are made worth so much money, but the companies are not, because there's no name in one Bitcoin company. You can't name even one that has any significant value. But the coin is super valuable. That's something we'll have to reconcile. So now we talk about the coins being valuable. So what are the type of coins? There's I categorize them into three different types of tokens. One is asset-backed security tokens. That is something that people are pushing really hard, but it's currently illegal, I would say, because why is security law? And the network utility tokens, this is what Bitcoin and Ethereum says. It awards people to build the network, prevents the network from being attacked, like the Bitcoin POW. But that's, you would argue there only needs to be so many network utility tokens. There's, the big network, there only be so many big networks. And then there's application utility tokens, which meaning that, like I build a Uber, and then I issue a token on top of it. And then I have some mechanism for people to trade this so that they can use it in a way that they can write taxi, right? That's but how to value those tokens? There's economic models to value those tokens, the application utility tokens in particular. That's I wouldn't get into details of those. If you are interested, we can discuss offline. But those are the three types of tokens. And the one that's I would say the network utility token is what's today, Bitcoin and Ethereum, and the asset-backed security tokens. If that happens, that's going to be huge because that essentially replaces the security market or can disrupt the security market. That's not just hundreds of billion dollars. That's trillions of dollars. Right? Application utility tokens is where we traditionally say those applications. So scale, well, I 15 minutes. So I said so much about the design of the cryptocurrency, the design of the cryptoeconomics, and I painted a big picture to say the economics engineering can now work hand in hand with software engineering to solve technical issues of the Bitcoin or of the blockchain. And you must ask me, well, how? That's give us some concrete examples where developers get. Let's just not talk about abstract concepts. So the first, as we discussed, one of the biggest performance bottleneck is consensus. Because it's decentralized consensus, so everyone has to agree. So the network performance is limited to the slowest computer on the entire network. And then even that computer has to do a lot of meaningless work in order to compete for the rights to record transactions. So the first thing you do is meaningful work in POW. So instead of just trying to find a hash, you're trying to make it meaningful. However, this requires a lot of design, but you can see a lot of projects like this now, to use the graphics card for AI training, to use it for data mining, to make it more meaningful. That's one of the training you can go, is to do a meaningful work in POW. That is, I would say, put squarely in the cryptoeconomics world, because that's you are modifying the POW to make the coin do something else, right? And then the second, which I think is the mainstream, idea of scaling, improving blockchain performance is called proof of stake. Proof of stake is very much like the early voting system, where your rights to vote based on the land you hold. And it sounds terrible, but it does make sense, because the more points you hold, the more stake you have in the network, the more you are interested in protecting the network. So you should have more rights in the network in terms of determining which transaction is legal and which transaction is illegal, right? So there's no meaningless work or computation, and it's deterministic. That's there's, unlike Bitcoin, you need to wait 10 blocks to confirm. Every block is final at every time. And however, it does not provide enough incentive to do good, because because no matter how many coins that I have for the system, I'm always a very small number. That's sometimes it's always more profitable for me to do evil. That's at other people's expense, right? So that has given rise to what we call DPoS, delegated proof of stake. All those are why we call it economics, because it's borrowed from the human society, the political economic system in the human society. The delegated proof of stake is Congress. So instead of everybody having to vote, we chose through the network protocol, we chose a Congress, we chose a council of people who represents us. However, those people have responsibilities to vote for us. They secure the network. If they misbehave, however, they're going to lose the collateral that they put up to become a congressman, right? That's, I think in human society actually we don't have this concept anymore. But that's but in here, there's you can elect delegates, and then the delegates have to put up their own money or coins as collateral, and then if they misbehave, their collateral can be slashed. So there's a whole complex, economic thesis in terms of how to do this. As you can see, this has nothing to do with computer engineering. This all has to do with economic design. But once it's done right, it secures the system. It solves a very classic computer science problem. It's how to secure a system like this, right? It has a risk of centralization. It has a risk of bribing. It's how do you prevent an outsider from bribing one of your representatives? All those issues that you have to work out to design right incentives for that. And then, there's other ways to do it, like the random algorithm-based consensus. You randomly pick people vote, and then, it's a representative process of this algorithm. But that's you can look at yourself. And then the second interesting approach to scaling is for sharing, and that's in fact is a very well-known problem, well-known method for scaling in computer science, right? That's when you have database, you always share. That's so that you can have multiple instances running in parallel. However, this is what we are talking about. Sharing is not engineering sharing. It's a different world. We have different economic zones to divide the blockchain world into different countries or into different industries. So it represents two different worldviews. that's when Ethereum first come up, and I think they still have to work. They want to be the world's computer. Everything about trustless computing should happen on their platform. But but more and more people are accepting a different world, which is there's an internet of interconnected blockchains, which means there's maybe hundreds of public blockchains, hundreds of public currencies, right? Cryptocurrencies, and they can all interchange with each other automatically in a protocol-based fashion, not in a human-based fashion. So then there's technical problems to solve, but there's also chief economic problems to solve. So I'm sure you've all heard of the word hot fork. That's people take the Bitcoin and fork it and do a Bitcoin alternative or whatever. And some of them are highly successful, but it's a huge mess. But here the idea of sharding, you can have what they call a hot spoon, meaning that you can have blockchains that connect each other and synchronize their states, right? Instead of forking, you can have them spooning and have them. So there's a ton of very, very interesting ideas. And one of the things that I say this as then because I just went outside. So the third approach from the cryptoeconomics point of view is to do the layer 2 network. And this idea is to say not all data goes into the public ledger. So for instance, if you want to have a public ledger to trade the medical data to people, you don't want the medical data to be on the public ledger. And then on-chain storage and computation are very expensive. Why? Because on-chain storage and computation have to work out every single node on the network. And so the idea is you could have a lot of off-chain transactions and then just add a hash of the whole transactions to the blockchain to make sure that so that they can verify each other, right? So there are different solutions. There's state channel, which sometimes you see Lightning Network or Raven. There's multiple related transactions can be verified together, and you can have what they call trio blockchains. You have children blockchains from the parent blockchains, and then that particular project, the famous project on that is called Plasma, and then you can pay other people with cryptocurrency to verify your results. A representative is true bit. So I know I've gone through all this really quickly, and there's many projects. They all came up this year. But I want to end this to say, this is why there's a value in the bubble, because all those ideas have been floating around for 3 or 4 years. Those are not new ideas. They never had money to try it. It has always been someone's white paper. And people say, because to build a network like that is very expensive. Well, the software itself may not be that expensive, but to build a network, to have people use it is very expensive. So, so you always have people to have, all kinds of different ideas, and they write it up, but they never be able to try it. But with the bubble, you have a huge amount of capital that's going to try everything. That's, I think 90% of them are going to fail. One or two projects succeed. We solve the performance and scalability of blockchains once and for all. So, that's one of the things that people say, it's really slow. That's, if you read the mainstream magazines or the newspapers, they always say, oh, it's really slow. It can never be used for practical use. That's e-commerce is years away. But keep in mind, with all this thing, none of this is rocket science. It's not a quantum computer, right? That's the fundamental problem that has been solved. The fundamental problem that we figured out is just to have a huge amount of money to let people try everything, try 100 different solutions and want to work out. And that's I think that's it. That's the end of the story. That's to me, that's what's most exciting. I can't say that my project would be the best or kind of win or whatever, but I think one of them is going to be very successful and maybe change the world with you. So